Dun, 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 dun. 7.2 bouncy collisions. All right, so welcome to physics lesson 7.2 bouncy collisions. Before we get started, what we need to do is talk about this thing called the conservation of energy. So basically, whenever we have a closed system, our energy remains constant. It's only changing forms. So it's not created, it's not destroyed, just the amount of energy that you put in stays there. It's just transferring from one type to another. And speaking of types, the first type that we're going to talk about is known as kinetic energy. Now we're going to get more into energy later on. I just wanted to start referencing it before we get into energy, which is our next section, because it makes sense in what we're doing now as well as what we're doing later. It kind of builds on itself. So kinetic energy, you may remember, is energy dealing with motion. And anytime an object has motion, it's said to have kinetic energy. And when we have two objects that come in contact with one another, we have a collision that's occurring. And the first type of collision that we're going to talk about is known as a bouncy collision or completely elastic. Now there are some in between, partially elastic, mostly elastic. We're not going to worry about that. It's either going to be completely elastic or completely inelastic. So this is a bouncy collision. So we have two objects. They have kinetic energy, they have momentum, they hit each other, and they remain separate. They don't stick together, they bounce. Bouncy equation is in red on your equation sheet, and essentially what this states is the momentum of object A plus the momentum of object B equals the final momentum of object A plus the final momentum of object B. Now, at the beginning of the year, I said that it's very important to start writing down your knowns and unknowns because as these equations get bigger and more complex, it's going to be hard or more challenging to keep them apart. And this is one of those situations. Basically, what we have is mass of object A, mass of object B, velocity of object A, velocity initial of object B, and then their final velocities, individual, because they are remaining separate. Go away. Nope, don't want that. Okay. Let's try that out. So let's say we have this, say truck right here, 12,000 kilograms. We'll call that mass A. 1,200, not 12,000. Kilograms. Velocity of A initial, and that is 5 meters per second. It's positive because it's rolling east. Then, to make matters worse, we have mass B, which is 500 kilograms, and velocity of the initial, which is negative 4 meters per second. Well, it's negative. Well, it's negative. Thank you so much for asking. Because it's going west. We also know that the final velocity of B is positive 12 meters per second. It was going towards the west, and now it is going east. Right? It was going this way, hit a truck pushed it that way. Now let's put it all together. So we have 1,200 times 5 plus 500 times negative 4. And that should equal 1,200 times velocity that we're looking for plus 500 times 12. $4,000 equals 1,200 V plus 6,000, so negative 2,000 equals 1,200 V V should equal negative 1.67 meters per second. So that means that the truck is moving backwards as well, but it's not moving as fast as the car. The car got more of that transfer. All right. Why don't we call that an end, and I will go ahead and shoot 7.3 sticky equations. Look at they stuck together. Okay, they're separate. That's not good. Now they're stuck together. Okay. Good times. What does that say? Don't run the risk. Yeah, don't run the risk of stopping on a railroad track. That's sound advice. All right. Talk to you later. Adios.